Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. In previous videos, I have discussed about various methods of different types of corrosion controlling methods. In this session, I am going to teach about different corrosion control methods. In this session, I am going to cover these topics: metallic coating, anodic metallic coating, cathodic metallic coating, and methods of applications of metallic coatings. In that, I am going to discuss about hard dipping, galvanizing, tinning, and electroplating. First, I am going to discuss about metallic coating. What is metallic coating? The surface of the base metal coated with another metal. Base metal nothing but the metal which is going to be protected. Base metal nothing but the metal which is going to be protected. That is called base metal. So, in metallic coating, the base metal will be protected by using other metal. That is called metallic coating. The surface of the base metal coated with another metal, that is our coating metal, is called metallic coating. In this metallic coating, our base metal will be coated with other metal, that is called metallic coating. Metallic coatings are broadly classified into two types. The metallic coatings are divided into two types. What are they? First one is anodic metallic coating and cathodic metallic coating. First, we are going to see first anodic metallic coating. What is anodic metallic coating? In anodic metallic coating, we are coating our base metal with anodic metals. Means the reduction potentials of coating metal will be less compared with our base metal. See, if you take one base metal, okay na? If you coated with other metal, that is called, maybe it is anode or cathode. The anode or cathode nature depends upon the reduction potentials of the metals. If the reduction potentials of the coating metal is less than that of our base metal, that acts as anode. Then our base metal acts as cathode. So, we are coating our base metal with the anodic metal. So, we are calling that as anodic metallic coating. The metal used for the surface coating is more anodic than the base metal, which is to be protected. In this anodic metal, our base metal is protected with anodic coating. Means we are coating with anodic metals. Means the reduction potentials of coating metal is less than compared with our base metal. For example, coating of aluminum, cadmium, and zinc on steel surface is the example for the anodic metal coating. Here our base metal is steel. We are coating with cadmium, zinc, aluminum. These are anodic metals. Anodic metals nothing but these are having less reduction potential compared with our steel surface. Okay. Therefore, anodic coating protects the underlying base metal sacrificially. In this, the coating metal acts as anode and our base metal acts as cathode. So, in electrochemical corrosion, we have discussed that anode part undergo oxidation and it will participate in corrosion. So, the other metal or base metal acts as cathode, that will be protected. So, in this case, therefore, anodic coating protects the underlying base metal sacrificially. Means the anode coating metal undergo oxidation and it will participate in corrosion. So, it sacrifices their life to protect our base metal. In the anodic metallic coating, what we are doing, our base metal will be coated with another anodic metal coating. So, that is called anodic metal coating. For what is the condition for anodic metallic coating? For anodic metallic coating, the reduction potential of coating metal will be less than compared with our base metal. Okay, that is the condition for anodic metal coating. Example for anodic metallic coatings are aluminum, cadmium, zinc. These are coating metals on steel surface. The steel surface is base metal that acts as cathode, and these coating metals aluminum, cadmium, zinc, these acts as anodes. So, these undergo oxidation. Means aluminum, cadmium, zinc, these surfaces undergo oxidation and our base metal will be protected. The coating metal dissolves anodically and the base metal is protected. Already I have discussed in previous videos. The anode part undergo oxidation. Means the coating metal, the anodic metal coating undergo oxidation. So, it dissolves anodically. Means it sacrifices their life and it will protect our base metal. If the formation of pores and cracks over the metallic coating exposes the base metal and a galvanic cell is formed. If our base metal is coated with some anodic coating, what happens if any cracks or pores are formed in this anodic coating? What happens? There is a formation of galvanic cell in this. This is cathode. The coating metal acts as anode. So, if it is exposed to environment air. What happens? Anode is there, cathode is there, so electrolytic solution also there, that is moisture. So it will form some galvanic cell reaction. If galvanic cell form, what happens? Anode undergo oxidation and cathode will undergo reduction. So it acts as galvanic cell. So our coating metal acts as anode. So it will undergo oxidation and it completely undergo corrosion and our base metal exposed to the air. Okay. Then second one is cathodic coating. In cathodic coating, what we are doing? Cathodic coatings are obtained by coating with cathodic metal. Our base metal will be coated with cathodic metals. What are they? The metals like tin, rm, silver, platinum. These are very cathodic metals. Why? Because the reduction potentials of these tin, rm and silver and platinum, these are very high compared with our base metal. So these acts as cathode. These coating metals tin, rm and silver, platinum acts as anodes and our base metal acts as these acts as cathode, our base metal acts as anode. In this, the reduction potentials of these cathode metals tin and rm and silver, platinum are very high compared with our base metal. So these coating metals tin, rm and silver, platinum acts as cathodes and our base metal acts as anode. So in this case, our base metal will be coating with these cathodic metal such as tin and platinum, etc. So this type of coating is called cathodic coating. In anodic coating, what we are doing? In anodic coating, our base metal will be coating with anodic metals. Okay. But in cathodic coating, we are coating our base metal with more cathode nature metals. Okay. Now those are tin, rm, etc. Okay. They protect the base metal as they have higher corrosion resistance than the base metal. In this case, our base metal will be protected with high resistance, means high cathodic metals. Cathodic coatings protects the metal when the coating is uniform and free from cracks. Okay, na? If any pores or cracks found on this cathodic coating, what happens? See, our base metal is there. We are coating with some cathodic metals such as platinum, tin, etc. So our base metal, in this case, our base metal is anode. Our base metal acts as anode. The protecting layer acts as cathode. But in case of anodic coating, our base metal acts as cathode and the coating metal acts as anode. But in case of cathodic coating, what happens? Our base metal acts as anode and our coating metal acts as cathode. In this cathodic coating, if any pore or cracks found on this layer, what happens? See, similarly, there is a formation of galvanic cell on our cathodic coating. If any pores or cracks are there, what forms? Galvanic cell is formed. Our base metal acts as anode and our coating metal acts as cathode. This is exposed to moisture. What happens? Galvanic cell is generated. See, in galvanic cell, which acts as anode? In this, our base metal acts as anode. The coating metal acts as cathode. So, if it is exposed to the moisture, so anode part means our base metal undergo corrosion very easily. In case of anodic coating, the coating metal acts as anode and our base metal acts as cathode. So there is corrosion undergo which part? Only coating metal undergo corrosion. But in case of cathodic coating, if any pores or cracks are there, our base metal first undergo corrosion. Okay. The cathodic coating protects the base metal only when the coating is uniform and the cracks are not there. Okay. Now if our metal coating should be free from cracks or pores, then only it will protect our base metal. The formation of pores over the cathodic coating exposes the base metal anode to environment and galvanic cell is set up. Already I explained how the galvanic cell is set up. Our base metal is coated with cathodic coating and if any cracks or pores are there on our surface, so it acts as galvanic cell. This causes more damage to the base metal compared with anodic coating. In cathodic coating, these cause more damage to the base metal, means pores or cracks are there, it undergo corrosion very fast compared with anodic coating. Methods of applications of metallic coating. In that I am going to discuss about hard dipping. What is hard dipping? Hard dipping process is applicable to the metals having higher melting point than our coating metal. Means what is the condition? Our base metal means the metal which will be protected, that acts as base metal. Okay, na? The base metal should contain more melting point compared with our coating or dipping metal. Okay, hard dipping process is applicable to the metals having higher melting point to the coating metal. The coating metal should contain less melting point compared with our base metal. Our base metal should contain more melting point in this hard dipping process. It is carried out by immersing well cleaned base metal in bath containing molten coating metal. In this hard dipping process, what will you have to do? Take some coating metal in molten state. Molten state means some liquid state. Okay, na? In boiling, if you melt the solid, we will get the molten state. Okay, the molten state metal we have to take in some container. Then we have to dip our base metal into that molten state metal. Okay, na? In this process called is hard dipping. In this process, what is the condition? The coated metal. Okay, na? The coated metal should contain less melting point compared with our base metal, or our base metal should contain more melting point compared with this coated metal. Example, coating of zinc, lead, aluminum or iron steel is the example for hard dipping. In this hard dipping process, our iron steel surfaces are immersed in the molten states of zinc, lead and aluminum. These are the example for hard dipping process. The most widely used hard dipping process are two. What are they? Galvanizing and tinning. These are the mostly used hard dipping process. First one is galvanizing, second one is tinning. See, we are going to see galvanizing. What is galvanizing? In galvanizing process, we have to protect our base metal. We have to protect our base metal with zinc coating metal. Okay, na? We have to protect our base metal with zinc coating metal. Means our base metal will be immersed in the molten zinc solution. That is called galvanizing. In galvanizing process, our base metal will be protected with help of zinc coated metal. So, that is called galvanizing. Galvanizing is a process in which the iron base metal is protected from corrosion by coating it with thin layer of zinc. Our base metal will be protected from corrosion with coating with zinc, molten zinc. That is called galvanizing. It is the anodic protection offered by the zinc. It is the example for anodic protection. Means the base metal, this is base metal. We are coating this base metal with zinc, molten zinc. It is example for anodic protection. Means this zinc acts as anode. Okay, our iron acts as cathode. Okay, means the reduction potential of zinc is less compared with the base metal. So the zinc acts as anode and our base metal, steel or iron metal, acts as base, or means cathode. Our zinc metal acts as anode and our base metal acts as cathode. This is the example for anodic protection of the anodic protection. In galvanizing, what we are doing? In galvanizing process, we are protecting our base metal, iron metal, with help of zinc metal coating. Okay, na? This is called galvanizing. See what we will do in galvanizing. In this process, its first iron steel is cleaned by pickling with dilute H2SO4 solution for 15 to 20 minutes at 60 to 90 degrees centigrade. In the first step, galvanizing, in that first step, we have to clean our base metal or iron metal by using dilute H2SO4 at 15 to 20 minutes at 60 to 90 degrees centigrade. That is called pickling. What is pickling? You have to clean our base metal. In the first step, you have to clean our base metal by using dilute H2SO4 at 60 to 90 degrees centigrade. It is called pickling. In the pickling process, what happens? That oil, grease or rust and any other impurity present on our base metal will be removed by using pickling process. By pickling process, we can remove any grease or oxides or any impurities present on our base metal will be removed by using pickling process. What is pickling process? Our base metal will be cleaned by using dilute H2SO4 at 15 to 20 minutes for 15 to 20 minutes at 60 to 90 degrees centigrade. This process is called pickling. By pickling process, we can remove the impurities present on our base metal. The iron base metal is washed well and then dried. After then pickling, we have to wash with water and then dry our base metal. It is then dipped in bath of molten zinc maintained at 425 to 430 degrees centigrade. In this step, what we have to do? The zinc metal, it will convert into molten state zinc at 425 to 430 degrees centigrade. The surface of bath means molten zinc is kept covered with ammonium chloride flux to prevent the oxide formation. Okay, na? In this step, what we are doing? We are heating zinc metal to at 425 to 430 degrees centigrade. It forms molten zinc. Okay, na? This molten zinc will be protected from by using ammonium chloride. How we can protect? Why we have to protect the zinc? Zinc reacts with oxygen, forms zinc oxide. So to avoid the zinc oxide formation, we have to protect molten zinc by using ammonium chloride flux. If molten zinc is there, if you form one layer with ammonia chloride flux, then it will prevent the oxidation. Molten zinc will not participate in the oxidation, means it will not form zinc oxide in presence of ammonium chloride flux. Okay. See, this is the diagram. See, in the first step, iron sheet. This is the iron sheet. We are sending into the dilute H2SO4 at 60 to 90 degrees centigrade. That process is called pickling. In this pickling process, what we are doing in the pickling process, we are removing the impurities present on our base metal like oxides, grease, any oil that impurities are there, we can remove by using pickling process. In pickling process, we have to use dilute H2SO4. We have to clean that at 60 to 90 degrees centigrade. Then we can remove any impurities present on our base metal. Then we are sending our base metal into the washing bath. In this washing bath, we can remove the impurities and also excess dilute H2SO4 on the surface of the base metal. And we are sending our base metal into the drying chamber. Okay, na? In drying chamber, we have to send hot air from this. Okay, na? So first iron sheet is sending into the dilute H2SO4, that is called for pickling process. We are sending our base metal. Then after we have to wash that our base metal. Then we have to dry by using hot air. Okay, na? Then we have to send into the drying chamber. In the drying chamber, hot air ovens are there. Those are dry our base metal. The next step, we are immersing our iron sheets into the molten zinc at 425 to 430 degrees centigrade. At 425 to 430 degrees centigrade, zinc is in molten state. Okay, na? In that, we are dipping our base metal. Okay, na? This is ammonium chloride flux. This crossed one is ammonium chloride flux. What is the use of ammonium chloride flux? Ammonium chloride flux prevents the oxidation formation of molten zinc. Okay, na? This will not allow the oxygen from outer atmosphere. So zinc will not undergo oxidation. So what is the purpose of ammonium chloride flux? Ammonium chloride flux avoids the oxidation of molten zinc. Okay, the oxidation of molten zinc. Okay, then we are immersing our base metal into the molten zinc at 425 to 430 degree centigrade. Then after this, here what happens? Our base metal will be coated with molten zinc. Then for uniform coating purpose, we have to send the zinc coated base metal into the pair of hot rollers to get uniform structure. To get uniform structure or uniform coating, we have to send our base metal coated with zinc. Okay, na? These coated metal, our base metal coated with zinc, these sheets are sending into the pair of hot rollers to get uniform thickness or uniform coating sheets. So then after, we can annealing chamber, then we can design, we can bend or we can prepare iron coated zinc sheets. Okay, na? According to our requirement. This is the process of galvanization. In galvanization, what we are doing? In first step, we are doing pickling. What is pickling? Pickling nothing but we have to clean our base metal by using dilute H2SO4 at 60 to 90 degrees centigrade. What is the purpose of pickling? In the pickling process, we can remove any dirt or oil or grease impurities present on our base metal. Then after pickling, what we have to do? We have to send our base metal into the washing bath. In washing bath, we can remove these all impurities and excess of dilute H2SO4 present on base metal. Then after we have to send this base metal into the drying chamber. In drying chamber, the base metal will get dried. Then after we have to immerse these base metal or iron sheets into the molten zinc at 425 to 430 degree centigrade. In that we have to use ammonium chloride flux on molten zinc. What is the purpose of ammonium chloride flux? Ammonium chloride flux prevents the zinc oxidation. Means zinc will in presence of ammonium chloride flux, zinc will not undergo oxidation. So that is the purpose of ammonium chloride flux. Here what happens? Here our base metal will be coated with zinc. Okay, zinc coated base metal. This zinc coated base metal, to get uniform coating, we have to send this in zinc coated base metal into the pair of hot rollers. The pair of hot rollers can remove the excess coating by using this pair of hot rollers. This pair of hot rollers, what their purpose? The pair of hot rollers that remove the uniform coated iron sheets, and also it removes the excess coated zinc. We can collect excess zinc removed from this pair of hot rollers. Then the zinc coated iron sheets are sent into the annealing chamber. See. Galvanizing is widely used for protecting iron exposed to the atmosphere. By using galvanizing process, we can prepare roofs, wires, fences, pipes, etc. In these cases, iron is coated with zinc metal. Galvanized metallic sheets are not used for keeping eatables because of the solubility of zinc. These galvanized metals means our base metals is coated with zinc metals. These galvanized metals should not use for the eatable purpose because zinc is very soluble in water. So these are not used for eatable things. The zinc coated or galvanized metals will not be used for eatable things packing. Tinning nothing but, in previous case what we did, our base metal will be protected with zinc metal. But in case of tinning, what is the process tinning? Our base metal will be protected by using tin. This is called tinning. In galvanizing, our base metal will be protected with zinc. But in case of tinning, our base metal will be protected by using tin metal. That is called tinning. The process of coating tin over the iron or steel base metal to protect from corrosion is known as tinning. To avoid the corrosion, our base metal will be protected with tin. That is called tinning. Tin is noble metal and therefore it possesses more resistance to chemical attack. Tin is a noble metal, so it is high resistance power to the corrosion. It is the cathodic protection offered by the tin. In the galvanizing, that is anodic protection. Means zinc acts as anode and our base metal acts as cathode. But in case of tinning, it is example for cathodic protection. Means tin acts as cathode, our base metal acts as anode. In this process, iron sheet is treated with dilute sulfuric acid to remove any oxide film if present. Similarly, in case of zinc also we did pickling. In this process also, first we have to pickling. Pickling nothing but we have to remove impurities like grease, oil, etc. by using dilute H2SO4 at 60 to 90 degrees centigrade temperature. That is called pickling. By using pickling, you can remove the impurities. What is the acid we have to use in the pickling? Dilute H2SO4 is the acid we have to use for pickling process. See, this is iron sheets. We have to send into the acid for pickling bath. Okay, na? For pickling purpose, we have to send our iron sheets into this dilute H2SO4 solution. Then we have to immerse into the tinning process. We are sending our base metal into the acid. Okay, acid. In the acid, we have to do pickling. What is the pickling? We can remove any impurities present in our base metal. First step, we have to do pickling. Then after, we have to send into same drying chamber, all those things. Then after, we have to immerse our base metal into first molten zinc. We have to dip into the molten zinc. The molten zinc is covered with ammonium flux. First in tinning, what we have to do? In tinning process, we have to coated our base metal with zinc. Our base metal coated with zinc. Then after, we have to coat this metal coated zinc metal with tin. That is called tinning. In tinning process, we have to coat it with two metals. In galvanizing process, we have to coat it with our base metal with zinc metal only. But in tinning process, we have to coat it with two metals. In first one, our base metal coating with zinc. In second step, this zinc coated metal with again coated with tin. That is called tinning. See, after pickling process, we have to send our iron sheet into the molten zinc. Then after, here what happens? Our base metal is coated with zinc metal. Then after, we have to send this zinc coated metal into the molten tin. Okay, na? Again, it is coated with tin. Then after this, to protect the tin from oxidation, we have to dip into this our base metal. Then we have to coat with zinc. Then after, we have to coat with tin. In this process, our base metal is protected with first zinc. Then after, we have to coat it with tin to avoid the corrosion of tin. Okay, na? We have to dip this total coated our base metal with palm oil. Okay, na? First step, we have to coat our base metal with zinc. Then after, we have to coat with tin. Then after, we have to immerse this zinc tin coated metal into the palm oil solution. Okay, to get uniform sheet. Then we have to send these into the hot roller pairs. Then after, we get the uniform thickness containing coated our base metal. What are the applications of tinning? See, these are the applications. Tin metal possesses good resistance against atmospheric corrosion. Tin is noble metal, so it will have high resistance to the corrosion. Tin is non-toxic and widely used for coating steel, copper and brass sheets. Tin is non-toxic, so we can use for any you can use for coating metal for any base metals. The container coated with tin are used for storing foodstuffs, geese, oil, etc. and packing food materials. In case of galvanizing, our base metal is coated with zinc. So in this case, we can't use zinc coated metals for the eatable things package. Why? Because zinc is very soluble in water. So that is toxic metal. But in case of tinning, tin is non-soluble. So we can use for making cooking packages, all those things, equipment and refrigeration purpose. We can use tin coated base metals. These are the application of tinning. Then next we are going to discuss about electroplating. Before going to electroplating, we have to discuss about electrolysis. What is electrolysis? Electrolysis is nothing but we have to send power into the electrodes. Okay, na? What is electrolysis? The conversion of electrical energy into chemical energy. That process is called electrolysis. In this electrolysis, what we have to do? For anode and cathode, you have to connect battery and electrolyte you have to take. In this process, the electrical energy you have to supply. The electrical energy convert into chemical energy. That process is called electrolysis. See, electroplating. What is electroplating? The process of depositing the coating metal on the surface of base metal by electrolysis process called electroplating. In electroplating, what we are doing? We are depositing we are discussed about coating metal. What is coating? What is galvanizing? What is tinning? In galvanizing tinning process, our base metal will be coated with other metals. In electroplating also, we are coating with other metals by using electrolysis process. That is called electroplating. In electroplating, what happens? The coating metal is deposits on our base metal. That is by using electrolysis process. That is called electroplating. The base metal, let's take the base metal ornament, that is copper bangle. Means our base metal is here copper bangle. We have to protect our copper bangle from corrosion by using negative terminal of battery to act as cathode. So in this process, what we have to do? See, in electroplating of copper, so we are taking our base metal acts as cathode. So that for purpose we are taking copper bangle. Okay, na? We have to take base metal as copper bangle. So copper bangle should be protected. So how we can protect this copper bangle? So in electroplating, you have to. This is the copper bangle. Okay, na? This copper bangle should connect it to the negative terminal of battery. So it acts as cathode, that is negative terminal. The negative terminal of battery is connected to the our base metal, that is copper bangle. So other terminal, the positive terminal of battery is connected to the Rm, means gold metal. So what is the electrolyte solution? Anodic solution takes as electrolyte. So here is cathode is our base metal, that is copper bangle. What is anode? Anode is Rm, that is gold. Okay, na? What is electrolyte solution? Anodic solution is electrolyte solution, that is AuCl3. See, the negative terminal connected to the copper bangle and the positive terminal connected to the Rm, and here electrolyte solution is AuCl3. AuCl3 is electrolyte. It decomposes into Au plus and 3Cl minus. So this is negative terminal, this is positive terminal. The electrolyte is present in the electrode systems. Okay, these positively charged ions migrate towards this negative terminal, that is towards copper bangle. These 3Cl minus ions migrated towards this anode positive terminal. So at copper, what are the ions present? Au plus 3 present. At anode, what are the ions present? Cl minus ions are present. Already we discussed at anode, what happens? At anode, oxidation takes place. So Cl minus ions undergo oxidation, forms Cl2 and releases 2 electrons. So here at anode, what happens? Chloride gas is evolves, and these electrons are released. After then what happens? At reduction, at cathode, what is there? At cathode, copper bangle is there. Copper bangle is surrounded by what? Au plus 3 ions. At cathode, what happens? At cathode, reduction takes place. So copper is there, copper bangle is there. These copper bangle is surrounded by Au plus 3 ions. At cathode, what happens? At cathode, reduction takes place. So Au plus 3 undergo reduction, forms Rm. So this copper metal, our base metal, is protected with metal, that is Rm. So in electrolytic plating, what happens? Our base metal will be coated with Rm metal. So this is the example for electroplating. See, in electroplating, what we are doing? Our base metal is connected to the negative terminal of battery, and the coating metal that is connected to the positive terminal of battery, and anodic solution takes as electrolyte solution. Okay, then our base metal acts as cathode and the coating metal acts as anode. At anode, what happens? At anode, oxidation takes place. At cathode, reduction takes place. So at cathode, our base metal is surrounded by these positive charged electrolyte solutions. At cathode, reduction takes place and these metal ions converted into the metal. So our base metal will be protected with or coated with some other metal like Rm. This is the process of electroplating. See, the process of depositing the coating metal on the surface of base metal by electrolysis is called electroplating. The base metal ornament, example copper bangle, is connected to the negative terminal of battery. It acts as cathode. And pure metal Rm, which gives protective coating, is connected to the positive terminal of battery. It acts as anode. So in electroplating, we have to connect our base metal into the negative terminal of the battery, that acts as cathode, and our coating metal, that acts as anode, and we have to connect that anode metal to the positive terminal of the battery. Then the electrolyte is the anodic salt you have to take. See, electroplating of copper plating. See, in this, what you are doing? Anode is pure copper, cathode is our base metal article. In this, anode coating metal is pure copper, means that acts as anode. So we have to connect this pure copper into the positive terminal of the battery, and cathode is our base metal, so it will be protected. So we have to connect this base metal to the negative terminal of the battery. At anode, what happens? At anode, oxidation takes place. At cathode, reduction takes place. So electrolyte solution is copper sulfate. So see, these are two electrodes. Okay, this is our base metal, means that is base metal. This is pure copper. This is connected to the this is connected, base metal connected to the negative terminal of the battery, and the pure copper connected to the positive terminal of the battery. So electrolyte solution is copper sulfate. So this acts as, the pure copper acts as anode, or base metal acts as cathode. This copper sulfate decompose into Cu plus 2 and SO4 minus 2. These negatively charged ions are migrated towards this positive electrode, and these positively charged ions migrate towards this negative electrode. So our base metal is surrounded by these copper plus 2 ions. Our base metal is surrounded by Cu plus 2 ions. At anode, what happens? At anode, oxidation takes place. So the copper converted into copper plus 2 and 2 electrons. At cathode, what happens? Our base metal is surrounded by Cu plus 2 ions. These Cu plus 2 ions undergo reduction, means it takes electrons, forms pure copper metal. So this copper will be coated on our base metal. This is the example for electroplating of copper plating. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.